Hey guys, a little early here. So I can't go live from my phone, which means I have to go live from my laptop. And I don't have any way of showing you guys any of my notes and stuff on Google Classroom. So I'm going to have it on my phone and I'll kind of access it that way. It's a little early. I said I wouldn't go live until 6, but I'm live here now to get it kind of set up. So hopefully this works and you guys can still send me questions like you normally would on Instagram Live. If it looks like this is not going to work, then I can always switch. I see a couple people have logged in. Cole is in. He's a regular for the reviews. Okay, I'm going to get in Google Classroom. If you have your STAAR stuff with you, I would suggest pulling it all out. That way you can kind of look at what I'm looking at and see it better since this is all we're going to have. Let's see. And if you can't hear me, let me know because I'm using my AirPods. And if that's not loud enough, I can turn the volume up or whatever, since I've never done it this way. So hopefully this works. Okay. Trying to send it through Google Classroom or yeah, Cole, they told me no live. Okay. They told me, yeah, I can't go live unless I have enough followers, which I clearly don't, since this is the first time I've ever done this. So, learning together. All right, sending this out on remind text. And then we'll get started. So my dog is locked up this time, so hopefully he won't be bothering us like last time and he's just barking nonstop. He's in the bedroom. He's not very happy. Okay. Yes, Cole is asking the STAAR test is 3 years. It is everything you learned in 6th grade, everything you learned in 7th grade, and everything you did in 8th grade. So it's a bunch. And I kind of mentioned this to some of the classes. I'm not sure which classes got it and which classes didn't, but the way Plano does it is the state of Texas says you should learn rocks, you should learn physics, you should learn chemistry, energy, all this different stuff. And Plano mixes it up so you learn a little bit of each subject each year that you have science in Plano. So luckily, you've had a little chemistry in 6th, a little chemistry in 7th, a little chemistry in 8th. So that hopefully helps you guys to be more prepared so you have a review of it every year as opposed to just getting it only once in 6th, only once in 7th, only once in 8th. All right. Still got about 5 minutes till everybody else kind of gets here. Cole says he wasn't here for this in the state of Texas for 6th and 7th grade. Hopefully, where you were, you got some of what you had. If not, on Google Classroom, I posted the link to get to some of the practice tests from previous years. So you could look at the test from last year, the year before last. You can look at the STAAR tests all the way back to like 2013, I think. Hello, Aiden. But the STAAR tests are out there, and then I put the videos out there. There's 4 different categories. They're called reporting categories. So if you look on the STAAR videos I put out there, the STAAR videos go over each reporting category. That way you'll know kind of like which areas to study. You can kind of see, and we did them all in class, but it's looking at it more focused. All right, if you go back to April 23rd on Google Classroom, if you go to April 23rd on the STAAR topics category, okay, Coco says, you know who I am, but I can't see your profile pic because the little picture is like the size of a centimeter. So whoever Coco is, I cannot actually tell who you are. All right, so this is the little booklet I was talking about. It has Einstein. You got it all in print as a packet. Oh, it's Linda. Okay. It's probably BTS as the picture. I just couldn't see it. Okay. And it's, there we go. All right, so I'm just going to use this STAAR booklet and I'll kind of tell you. So the very first thing it's going to talk about, and of course it's backwards for you guys. That's just perfect for us. It says energy transformations. So I know you did this in 6th grade. Hey, Tyler. I know you did this. Hey, Joven. I know you did this in 8th grade. We had it in 8th grade, but I know you did it in 6th grade too. But so law of conservation of energy, talking about how energy is not created or destroyed. Same thing as law of conservation of mass. Energy is not created or destroyed. It's only transformed. So wherever energy comes from, it's coming from something else. It can't just be created. You can't destroy it. So in the packet, the examples are chemical, which is stored up energy. Chemical energy is stored in your food, your muscles, your iPhone battery, any battery that you have. So for this one, it's chemical to mechanical because the person is riding a bike. So the energy stored in the food is converted to energy for the body. Tyler's asking how many questions there are. I think it's around 50. I don't know for sure. But yeah, I think that's what it was. You can look here. I'm gonna pull up. Tell me if, well, I'm gonna pull up on my computer. So the camera may still be filming me. I don't know because I'm not on that screen anymore. But I'm gonna look at the release test from last year, and that way I can give you an idea as to how many questions there are. Okay, I'm looking at the release test from last year. I see Aria is in. Okay, last year's test had 42 questions. So that's kind of a good range, anywhere from 42 to 50-ish. They could change it. I don't know. You'll know when you see your answer document tomorrow. Don't forget, don't just jump right into answering questions. Go in and do the periodic table like we all practiced. Do your moon phases. On your moon phases, you can label the seasons. You can label the tides, because all that kind of goes with moon phases. If you can get the moon phases. Cecilia's here. If you go watch they're like on the YouTube channel that I posted on the STAAR Google Classroom tab. But if you look and it says hacking the STAAR, like it's not really hacking the STAAR. It's just ways for you to do a brain dump to kind of help you know what to put on your periodic table, what to put on your formula chart. Change your 3 formulas into 12 or into 9. It used to be 4 and 12, but now it's 3 formulas. You can put those into 9 formulas because you can use the triangle. What are you talking about, Tyler? I don't got a million subs. I only have 10 people watching this video. Yes, Cole, the periodic table thing we did in class, that's where you guys, did 8-man and you talked about metals versus non-metals. Hey, Reedy. We talked about, gosh, what else is on there? Reactive elements. So your group 7 is going to be close to least reactive. Group 8 is very least reactive at all. They're stable. They're the noble gases. They're never going to react. And then if you go from 7 to 6 all the way over to group 1 is most reactive. Those are going to react pretty much with everything. They're trying to get rid of that 1 electron because they're in group 1. And so they will react and bond with anything and whatever to try to get rid of. Cecilia says, does it have 6th grade science? Yes, it's going to have 6th grade. But I taught 6th grade like 6 years ago, so I don't know how much it's changed. Thank you, Arjun. Yes, I just don't bring them to school. He says, nice AirPods. I don't bring them to school because I don't want them to get stolen, or if I leave them at school, then I don't have them at home. So, yes, I have AirPods. But yeah, 6th grade, you did energy, you did physics, you did chemistry. Aria says, can you go over how to find net force? So net force is just like adding the forces up. So if I have an object pushing this way with a force of 5 and an object pushing this way with 2. So going to the left, which I hope that's your left, is going to be negative. So that's -5 to the left, but 2 to the right. The net force there is going to be 3. So always remember up and down. I'm sorry, up and to the right. Let me draw it. And I know you can't see it. I'm going to put it up for you to see in a minute. Okay, so if it's going up or to the right, then it's positive. If it's going down to the left, it's going to be negative. Oh, can you hear my dog? He's barking. So if it's going positive, right, or up, down is left or negative, and you're going to add them up. So I would go through first and figure out which one's positive, which one's negative, and then you just add them up. So think of it as money like I did in class. So if I say, I have $10 and I owe you 8, then how much do I have left? That's positive 10, negative 8. And then Cole says, whichever way has more force, that's the directions it moves. That is correct. So if it's got a positive 5 to the right and a negative 2 to the left, then that's actually going to be a positive 3 to the right, and that means the object would move to the right. What tells us what elements are most reactive and most stable? I saw that question. So if you're looking at the periodic table that we did, the periodic table we drew that across the bottom. So your most reactive is always group 1. Least reactive is always group 8 because they're stable. They're your noble gases. They don't want to bond with anything. Your group 1, and I kind of said this at the beginning of the video, or about 5 minutes ago, your group 1 is most reactive because those have 1 valence electron. They got to get rid of that 1 valence. Because if they get rid of that 1 valence, they're totally stable, and that way they can be happy like a noble gas. Like they're going to have their outer level is full. So if they get rid of that 1 valence, they're happy. So that's why they're going to react the most. Cole asked to go over topography stuff. And again, we're going to have to go off my tiny phone here. I should have brought my iPad out here. But my dog's in the other room barking. You can probably hear him. Sorry. Okay, so there's a topographic map. It's not going to focus. Wonderful. You can kind of see it there. So the index contour is the bold labeled lines. So that's the line that's with numbers. Those are the index contours. All the lines on the whole map are called contour lines. Each line, so if the contour interval, usually it's going to give you the contour interval. If it says contour interval is 50, then that means every line is going to go up by 50. Unless it has hasher marks, then that means it's a decrease or a depression. It's a hole. It's going to go down. Okay, so that means if it goes up by 50, it's also going to go down by 50. So look for the contour interval. They tell you what the contour interval is. Someone's asking about math, grade 7. I don't know, but I'm not a math teacher, so I can't really help you with math. We have our STAAR test tomorrow, so that's what we're doing. So Cole, did you have any other questions on topography? If the lines are very close together, it's steep. If the lines are very spaced apart, that means that it is a very gradual elevation. It's like a hill. It's opposed to a big mountain. It's not going to be steep or hard to climb up. So hopefully that helps. Let's see. Looking at, so chemistry, if you're on the little booklet thing. Okay, Linda, you can't be telling me that, so don't mention anything else because that's not okay. Let's go back to physics because somebody asked about net force. Cole's asking, well, we have to find out how much it goes up the mountain each time. They should tell you the contour interval, which is like how much elevation it goes up. They should tell you how much it goes up. So hopefully it will tell you. Look for it to say contour interval either at the top of the mountain or the bottom of the picture or whatever. So look for that. If they don't tell you the contour interval and it asks you to find contour interval, then it's going to be take the first index contour, let's say it's 200, and then the one, there's 3 lines, and then it's, 500. Then you're going to need to subtract, and then you count the spaces. Don't count the lines, you count the spaces, and you divide by that. So, and then after you've done that, check your math and see, does each line go up 10, 20, 30, 40, or is it 50, 100, 150, whatever they think, whatever you think the contour interval is, see if it actually works out. Tyler says, is there a lot of 7th grade questions? I honestly don't know. All I can tell you is that looking at years past tests, because I don't know what's going to be on the test from year to year, looking at years past, there's some 7th grade, but the ones that you're going to see, there's always typically a food web or a food chain. So understanding producers are your lowest level. Those are the ones that make their own food. Consumers, you and I are consumers. We have to go find our food somewhere else, whereas producers make their own food. So producers are plants, phytoplankton if you're in a marine food web or an ocean food web, trees, shrubs. Those are all your producers because they're making their own food. Consumers are your plant eaters, and then your secondary consumers are like lions. So they could eat meat, or they could eat, well, they're all going to eat meat, lions are, but like smaller animals or like medium-sized animals, but they're eating another consumer. Tyler says, is my shirt Go Astros? No, it's actually a Rangers player. It's a long story, but Orbit, the Astros mascot, was doing like a dance thing before the game, and Ronald Guzman, who's this guy, went up and did a bunch of the Fortnite dances, and he always does the splits, so he landed in the splits, and so Orbit's dead because Guzman got him in a dance fight. So no, they're not, Tyler. No more Astros baseball talk. We have got STAAR stuff. Lourdes is asking about genetics. Somebody else has asked about genetics. I can tell you, I have not done genetics since I was in like high school or college. So Punnett square, there is a Punnett square in the packet little thing that we gave you. And then you've got definitions of heterozygous, which is 2 different alleles, homozygous, which is 2 same. So you can think homo meaning same, hetero meaning different. That helps you remember that one. Recessive traits are those that are hidden. Dominant are those that come out. Tyler says, what is a Punnett square? A Punnett square is, or no, that's Cole's asking, sorry. That's a Punnett square. It's, so you would take the mom's traits or genotype, and then you take the dad's, and then you would just see what happens. So like if the mom has a dominant and a dominant, then you're going to end up, the baby's going to have a dominant dominant. If you have a dominant and a recessive, then you have a dominant recessive. If you have recessive dominant, dominant recessive, and if you have recessive recessive, then the baby's going to have recessive recessive. So I don't know a lot about, like I said, genetics. Like I have not had that since like high school or college. It's been like 15 years. So, but there's not a lot, I would guess, just because, well, we don't have very much on our review thing from it. I would know the nucleus is where the DNA is located. That's a big one because it's parts of a cell. A chromosome are found in pairs. They're in the nucleus. They carry the genes that determine the characteristics of what the organism is going to inherit. So like your blonde hair, brown hair, blue eyes, tall, short. The hitchhiker thumb, I know that was one that we always did. Yeah, so unfortunately my genetic stuff is not super on point. No, Arjun, I've not seen the STAAR test. We're not allowed to see it. I'm not allowed to look at it tomorrow. So I won't see the STAAR test until like next year when they release it. But I posted on Google Classroom a link to last year's test, and you can go look at that and you can see all the questions. So yes, we look at the ones after they've been released, but I have no access to look at the test I can't look at it. I'm not allowed. So I have not seen it. That's why somebody asked how many questions are there. I honestly don't know exactly. Last year's test had 42 questions, so that's all I can look at. So I know nothing about the actual test other than you get the periodic table and you get the three formulas for second law, which is force equals mass times acceleration, speed is distance divided by time, and then density, which is mass divided by volume. So that's all I know about the actual test itself. Everything else I have to guess or speculate or base my answer off of last year's test. All right, go back to review. What other questions do you guys have about what you're going to have to learn? Yes, Cole, you will get a formula chart. The ones that we use throughout the year that has the periodic table on one side and you flip it over as the periodic table, on the back of the periodic table is the formula charts. That's what you're going to get tomorrow. It will not be the blue one like we used in class. Ours are just blue. And then it will not have any of your notes on it because you have to use theirs. That's blank. So as soon as they give you a chance to start your test, go write down all the stuff we talked about. 8-man, reactive, non-reactive, metals, non-metals. What was I looking at on my phone that had the Punnett square? So if you go to Google Classroom and you click on the STAAR topic, like on the left side, all the topics, like all the different units we've done. If you look on the STAAR topic and go to April 23rd, I posted a little booklet that has the Albert Einstein face. Remember that guy? It's like a little brochure booklet thing. That's where that's what I'm using to kind of review and go over because it's just an overview from everything. So for, I think, mango juice, that was Reedy. That's where the Punnett square stuff was. Let's see. Cole is asking, can we go over rocks? So I used to teach rocks forever in 8th grade, and then they moved rocks to, I think, 6th grade, which kind of made me sad a little bit because I did like going over rocks. Let's see if I can have any pictures to help you. There's 3 main rock types. Your igneous rock types are your lava rocks or fire rocks, and they're called that because they come from volcanoes. Then those two, that one type, igneous, gets broken down into intrusive or extrusive, intrusive or underground, extrusive or above ground. I don't think they're going to get that much into it, but those of you that do Minecraft, you have whatchamacallit, the obsidian or whatever it is. That's like a big thing in Minecraft. That's a volcanic rock because it's cooled quickly, lava that's cooled quickly in water. You've got, so that's igneous is one type of rock. Sedimentary, which if you think of the word sedimentary, which comes down to sediment, that's the root word there. Sediment are tiny pieces of rock and dirt and whatever. So sedimentary rocks are pieces of rock and dirt that have been cemented together through a process called lithification. You can have organic, which means it's from living things like seashells or bones or like dead particles of like sea fish and hard crustaceans. Or you could have non-organic, which are like your rocks and like whatever. You know, like the cement that's very gravelly and like bumpy or whatever. That's actually a type of sedimentary rock because it's little pieces of rock that are cemented together. And then you could have a chemical sedimentary rock, and that's like where you have rock salt because it's a mineral, which is halite. It's a salty mineral that if that mineral is left in water, it becomes rock salt. It hardens. So my dad's calling. Hold on. Let me take this call and then yeah. Hey, Dad, can I call you right back? Okay, I'll call you around 7. Bye. Okay, sorry about that. I called him earlier today. No, you cannot listen, Tyler. I called him earlier today, and he's just now getting back to me. I guess he was in meetings all day. So I was talking about sedimentary rocks. There was the 3 types of sedimentary. So there's living sedimentary rocks, which is organic, non-organic, chemical, and non-organic, clastic and non-clastic, which is like living things that are pieces of rocks or like pieces of dirt and clay that are all cemented together. The 3rd type is metamorphic rocks. So metamorphic rocks can only come from the other 2 types. So that's when you have a lot of heat and pressure that's coming down, and it makes the rock, like it heats it really soft, and then it makes it flattened. And that, so if you have a rock that has big crystals in it, when you have a metamorphic rock, those crystals get melted. They're soft like a piece of gum or Play-Doh, and then they get flattened. So that is how metamorphic rocks come. So all three rocks could become one another. So if a sedimentary rock gets pushed too far down, it's going to melt and become a metamorphic rock, or it could come up as magma and get erupted, and now it's back to igneous rocks. How do we identify organic compounds, and why are they organic? So organic compounds is when you have a carbon. So look for the letter C. If it doesn't have the letter C, it's definitely not organic. But if it's got the letter C, and then it has to be bonded to either hydrogen or oxygen. So sugar, C6, H12O6, that's organic because it's a carbon with a hydrogen and an oxygen. So if you just had H2O, that's not organic because there's no carbon. So hopefully that helps. And then argon, if you're not 100% sure and you want to go back and look at our lesson, let's see if I can find it real quick. Cole is asking for organic compounds. Is it carbon and anything else? No, it actually has to have carbon and then either a hydrogen or an oxygen. So argon, I'm scrolling all the way back to chemistry. Oh my gosh, I'm only in March. I got a long way to go. I'm double checking argon to see if it has to be both because I'm not 100%. That was a long time ago that we did that. I don't want to tell you the wrong thing. Let's see. Oh, back to October. Universe. Getting into chemistry. Science fair. Back. I'm still in the universe unit, so give me a minute here. All right. Chemistry. Lots of good stuff here. There's all the different lessons that we did. There's a Quizlet. There's lots of Quizlets out there. Yes, that's a custom pop socket. That's my dog. When I went to the website, I was going to try to get a pop socket, and I didn't see any that I liked. And I was like, I'm not staring at something that I don't like. So when I went to the website, it was like, create your own. So yeah, I made my pop socket my dog. Okay, let's see. I don't remember which lesson. There's also a review. If you wanted to do a chemistry review, my Instagram live from the chemistry unit is attached to Google Classroom. So you could go back and watch that. It's an hour, but you could still go back and watch that. That's really neat that your pop socket is science. Too bad you didn't notice. Okay, let's see. Where is organic? Probably not balanced. I think it's going to be the Ides have it. Let's check and see. Tyler's asking about body systems. I would definitely look over the body systems. If you have that little Einstein booklet, or if you get on Google Classroom and look at the Einstein booklet, it goes over all the body systems. Okay, perfect. If you look in the Ides have it, it was posted September 11th. There's 4 attachments. There are notes and questions, but it says an organic compound contains carbon bonded with hydrogen and oxygen, and it looks like a couple of other elements as well, but definitely carbon, hydrogen, and oxygen. You do not have to know parts of the body. Someone's asking about the body parts. That you definitely do not have to know. You just have to know the systems. So like circulatory is your blood, respiratory is your breathing, your nerve system is your like brain, your neuro system, whatever, skeletal system, muscular system. Those are pretty basic. Digestion, endocrine is like your like body's hormones and like responses and things like that. And then your excretory is like going to the bathroom. So yeah, definitely look over that little booklet. Aria says, can I explain parasites, relationships? So a parasite would be like a bug or something that lives on you, like a tick or a leech. because they get their food from the host. So I would be the host if I had like a leech, which is like a little like a slug that like attaches to your arm. It's really disgusting. Or your arm, your body, anywhere. So a parasite attaches. Sometimes there's a good parasite-host relationship. That's called a symbiotic relationship. That's where both of the organisms benefit. You see those like big sharks, and they have those little tiny sucker fish attached to the sides. Those little fish are parasites. But what they're doing is they're cleaning off all the algae and bacteria that form on the sides of the shark. So the shark benefits and the parasite benefits. So that's a symbiotic parasite host relationship. Sometimes, if it's like a human with a tick or like a worm, like ringworm, or like if you get a worm inside of your food, or like I don't know, like your dog gets ringworm and whatever, that's bad. That's where the parasite damages or hurts the host. And I forgot what that's called. It might be in that little booklet. Let me see. But so yeah, there's two types of parasite hosts. Hopefully, Aria, that helps to answer your question. I know there's a little bit of it in that booklet, so I'm going to go back and look and just see. Was there more about parasite host, Aria, that you wanted, or did that kind of cover it? I know that was pretty basic because, like I said, I haven't done that since sixth grade, maybe. I think we did a little bit of parasite host. Let me look and see. Okay. Oh, my dog is in there whining because he can hear me talking. I turned on a TV to like block out my sound, but clearly not. Okay, so in here it's talking about parasite host, and it just shows a little flea living on a dog. So the flea in that case is the parasite, the dog is the host. That's not a mutual parasite. Like they don't like it because the dog itches and bites and scratches. It doesn't actually go into the mutual things that I was talking about. So that was actually a little bonus for you guys. That looks like it's higher level stuff. But look, the marine one it talks about is how whale have little louse that feed off of the whale. The whale is, it is harmed by the whale. So it's a whale sucker, and it's bad because it hurts the whale. But for sharks, they like them. I know that. Thanks, Tyler. I think you're being sarcastic because I said I didn't remember it, but let's see. Autotrophic, auto means self. So that's an animal that's going to get, or an organism that's going to get food from itself, like plants. Heterotrophic means they're a consumer. They have to go out and get their food from somewhere else. We are heterotrophic. Our bodies do not make our own food. Will we need to know reproductive system? It's possible. It's possible you have to know any of it. If you go into the little booklet thing, there's a list of all the systems. And I saw your question, Tyler. I'll do that one next. It talks about the skeletal system, nervous, digestive, immune, lymphatic. So your lymph nodes, which you have some here, you have them in your armpits. There's like all over your body. But your lymph nodes help to fight against bacteria and viruses, same as your immune system. Yeah, Aria answered the question there, Tyler. I was going to get to it next, but your endocrine system is the glands. Like you have glands in your neck. You have glands down in your organs that can distribute hormones and help regulate bodily functions. Your integumentary system, I think in seventh grade, you wrote a letter to your integumentary system. I don't remember what that one is. It protects against the outside environment. Okay, it's like your skin, your nails, your hair. Circulatory is blood, excretory is your waste, and then muscular is your muscles. So Tyler had said is abiotic living. So biotic is living, abiotic is non-living. Abiotic is like anti. Tyler, if you're asking, should you cram study? At this point, the test is tomorrow. You are going to be cram studying. If you did not want to cram study, you should have started studying a while ago. But here we are. Let's see. So Cole says he's good on that. There's like a brief overview of all the different body systems. It doesn't have pictures, but it goes into like all the different ones. Plant cell and animal cell, I would definitely know the difference in a plant cell and an animal cell. The main difference is that a plant cell obviously is going to have chlorophyll and a chloroplast to make food because plants have to make their own food because they're producers. And then a plant cell also has to have a cell wall, and that's what helps keep it rigid and straight to help the plant stand up. Uh, Other than that, the cells are pretty much identical. If you look at that little booklet, it labels each part of the cell. Um, I mean, that's just kind of, you're not going to have to label the cell. It's going to ask you, if it gives you a question or what they've done in the past, if they show you a picture of a cell and it might say, in this cell, the nucleus contains the DNA genetic material, and then they'll ask a question about that. They're not going to actually say something usually about identify the nucleus. That's kind of a basic level question. They don't usually ask those. They like to ask more in-depth questions. All right, what else? That's one of our cells. I kind of did a brief overview of cells. What else? Space stuff. We've got galaxies, stars, universes. Uh, Sorry, I'm like sliding on the couch here because okay, there we go. Because I have this little table in front of me where my computer is. What else? What else I got? I know there's only like 9 of you in here. You guys are my rock stars. You're always the same ones that are in here. What else you got? Let's see. Uh, You got your unicellular organisms, or one cell, multicellular, a lot of cells. Aria says, can we go over physics unit? So physics, you've got Newton's 3 laws. First law is forever. Nope, just kidding. Hold on. An object in motion stays in motion. An object in rest stays at rest unless acted on by an outside unbalanced force. So if I throw a ball and I'm here on Earth, the ball is going to either stop because something or someone stops it, or because gravity pulls it to the ground. If I'm in outer space and I throw a ball, it's going to go on forever because there's no gravity to stop it, unless an outside force, like a rocket ship or another planet or an astronaut catches it, then it's going to stop. So that's the first law. In class, we did 2 different demonstrations. One was we had the penny on the index card, and if you pulled the card straight out, then the penny would drop into the cup, because the penny was an object at rest and the card was an object in motion. The penny stayed at rest when we pulled the card out. Newton's second law is force equals mass times acceleration. So for an object to accelerate, the force has to be equal to the mass times the distance it's going to travel. That one's going to always have, if it's asking you about that one, it's always going to have either the word force, mass, or acceleration in the question, or like whatever. Sometimes they'll give you one where you have to calculate it, so be sure you're looking at your formulas for that. Newton's third law, for every action, there is an equal and opposite reaction. So that's like if I am in a canoe and I paddle the boat backwards, I push the water this way, your boat is going to go that way. Or if you're swimming, when you paddle with your hands, your hand is pushing the water backwards, which is propelling your body forward. So for every action, there's an equal and opposite reaction. Aria, what else did you want from physics? Balanced and unbalanced forces. If forces are balanced, then it's not going to move. It's going to be at rest. If they're unbalanced, that's when we talked about that at the very beginning of the video. If forces are unbalanced, that's when you've got an object that's going to move. And if it's up or to the right, it's positive in motion. If it's to the left or down, it's negative in motion. I think that's all from physics. If you have any other questions about physics, remind me. Oh, speed. Gosh, there's a whole lesson on speed. Speed is equal to distance divided by time. So if an object is traveling, 50 miles and it takes 2 hours, what's the speed? So you would divide. Draw your little formula triangle. So if they give you the speed and they don't give you distance or they don't give you time, you can still figure that out. And then if it's talking about speed, it's just a number, 50 miles per hour, 3 meters per second, whatever. And then if it's velocity, it's going to have a direction and a number. So if I said 50 miles west, 50 miles per hour west, then that means it's velocity because it's a number and a direction. Okay, I'm not skipping you guys that are asking about kingdoms, taxonomy. and energy transformations. Tyler's asking about acronyms, some of them. Balanced forces have a net force of 0. That's correct. More energy transformation stuff. No, you didn't get rejected. I was just finishing up the physics unit. I will go over balanced force. I will go energy. Oh, we'll go over energy transformations and taxonomy stuff. Hold on. Okay. So, let's see. Oh, Tyler got rejected. Oh, well. All right. Someone had asked about taxonomy and stuff, and I'm going to refer to this because that's another one of those things that I have not looked at since 6th grade. So, there's 3 different domains: eukarya, which are animals, plants, and humans; archaea, which are bacteria that live in extreme environments; and then there's bacteria, which is kind of confusing because you've got bacteria that's archaea and then just regular bacteria. Um, but the bacteria they're talking about as its own domain, those are the ones that live in normal conditions. Like the bacteria on your hands, they get killed off by hand sanitizer. There's 6 kingdoms: archaea, bacteria, protists, fungi, plants, and then animals is the 6th. If you look at that little booklet, the glare is ridiculous. There's a little description of each one of them. Honestly, prokaryotic, eukaryotic, I do have a little memory trick for you guys on that one. All right, Cole and Tyler, you're going to be done if you can't stop arguing about who got rejected. All right, so eukaryotic are organisms that do have a nucleus. So if you can remember, euc equals nuke, then eukaryotic have a nucleus. Pro means no, prokaryotic have no nucleus. We're not talking about movies, so don't be talking about movies if you're on there. So I said euc equals nuke, pro means no, so prokaryotic have no nucleus. So that's on here. The smallest living thing is cells, then it goes up to tissues, organs, organ systems, and then the last biggest thing is the organism. And there's a picture of a prokaryote and a eukaryote on there. I was just talking about that. Unicellular versus multicellular. Unicellular is like viruses and bacteria, an amoeba. Multicellular is you and me. You have skin cells, blood cells, muscle cells, bone cells, brain cells, all different kinds of, every kind of organ and tissue has its own kind of cells. So those are all different types of cells. So you are multicellular for sure. Tyler says we need to know the butterfly life cycle. I mean, I honestly couldn't tell you what you 100% have to know because I haven't seen the test. My thought would be not specifically. It would be more like understand how a cycle works. Understand there's no beginning and no end. Yes, some of them have like a starting place, but like rocks definitely don't have a beginning or an end. It's just evolving all the time. Stars have a beginning. Most animals have a beginning, but their death can sometimes lead to the birth of the next one, like in the stars especially. So like not specifically memorizing any one animal cycle, but just knowing like how a cycle works, if that makes sense. So, I mean, I don't know. That's possible you do or don't have to know butterfly life cycle, but my thought and guess would be no. Can we go over the life cycle of a star? So you've got 2 different possibilities, and I'm going to do low mass first, then I'll do high mass. So both stars, all types of stars, began as a nebula. And that star-forming nebula is just a bunch of gas and dust. So gravity is going to compact the gas and dust, and that's going to form into a protostar. And the protostar, if it's a small, low-mass star, then it's going to have a long main sequence. That's the adult life of our star. That's where our sun is right now. It's in the middle of its main sequence or its adult life. So because the sun is low mass, it's got a long main sequence, a long adult life. After the low mass star goes through a long main sequence, it's going to go to a red giant. And then the red giant's going to start to swell and it's going to slough off these big like clouds of like star energy. And that's what's going to take in Mercury, Venus, possibly Earth, Mars. Sorry, I'm all like stopped up. Allergies. So after a red giant, it goes down to a white dwarf. and then a white dwarf is going to die off and become a black dwarf. All that matter that got sloughed off from the red giant and the white dwarf killing off down, burning down to the black dwarf, all that gas and dust that got put off into the atmosphere, that gas and dust starts the news cycle for a new star. That is the life cycle. That's, sorry, my couch, I'm slipping. I got it. Okay, much better. Just lost the pen, so I hope I don't see it. All right, you're at an angle now. Sorry. So that is the life cycle of a low mass star. That's not going to work because now my computer's going to fall. Okay, for a high mass star, you've got the nebula again, and then all the gas and dust, gravity compacts it, brings it together, and then the high mass star it'll have a protostar, so nebula, protostar, and then because it's a high mass star, the fuel and the gas and all that is going to burn much faster. So it's going to have a short main sequence or a short adult life, and then after that, it skips red giant, goes straight to super red giant. It's going to be huge and big. Because it's a super red giant, it's going to have a super big death. So it's going to go into a supernova. Now, from a supernova, it's got three different things. The explosion of the gas and dust from the supernova is going to create a new star. That's the gas and dust to make a new star that creates the star-forming nebula. And then if there's not enough gravity to balance out the fusion that's happening at the core of the star, so fusion is when you've got a hydrogen and the two hydrogens make a helium. So that's fusion that happens at the core of the stars. And they fuse until they have created a big enough, heavy enough thing that it's dead. But anyways, so if there's not enough gravity to balance out the fusion, then the star will swallow itself and become a black hole. So that's high mass only makes a black hole. And then a neutron star is the third option, and that's if there is enough gravity to balance off the fusion. Sorry, my brain's like, I'm trying to remember the picture. So 3 choices for a high mass star. The gas and dust comes in to make a new star. If there's not enough gravity to balance the fusion, then it becomes a black hole and it swallows itself. If it does, then it's going to have a neutron star, which is just kind of like a small basic dead star. What's the difference between fission and fusion? Fission is not something we've talked about. You're not going to have to learn about it until you get into upper level chemistry. Fusion is fusing, coming together. So if I've got a hydrogen and a hydrogen, I've now got helium. Fission is if I had helium and it got split, and now I have hydrogen and hydrogen again. Just splitting the atom. So fission is what Einstein came up with when he discovered the atom bomb. He didn't actually do it. He just knew the technology would create an explosion, and then that's when the government used it for, World War II. So lots of good questions. Still got about 10 people that are involved. Let me see what else is in here that you guys might want to ask about. Looks like watershed. I just got that one in here. I actually saw watershed on the Weather Channel, or not the Weather Channel, like the news, actual news, because of all the rain we've been having lately. They were talking about the watershed. I was like, oh, science. Okay, watershed. Oh, my dog is scratching at the door because he hears me. Sorry, I got scared. I was like, what is that noise? It's an area of land surrounded by a high ridge or higher elevation, causing water to run off and drain into a common surface and groundwater within the area. And then it gives a little picture, kind of hard to see since you guys are backwards. But it's talking about how if you have like a higher elevation of land, so like a hill, watershed is when it rains and then the water runs down the hill to the lower level. Okay, so it's gonna flow downhill because water can't go up. So that's watershed. And then it's gonna leave the earth. It's gonna go into the ground through groundwater. It's gonna get evaporated, and then it's gonna get taken up through the trees and transpiration. So that's kind of like the water cycle being involved with watershed. Let's see, what time is it? 6:45. If you guys have any more questions, I'm gonna kind of call it around 7 because I gotta watch The Bachelorette, sorry. But if you have more questions, I'll stay a little after. Atmosphere and weather. So land and sea breeze, all wind on earth, all energy comes from the sun. So if we did not have the sun, we would not have wind, we would not have energy. Um, but because of the uneven heating, you get land and sea breeze, which is what's happening here. So a land breeze happens because the land is going to heat up very, very quickly in the daytime. So that heat that's on the sand, the air above it is going to rise up. You can't dislike this, Tyler, after you said I was helping you. Come on now. Uh, so the hot sand will create hot air. That hot air is going to rise, and the ocean will naturally be cooler because water takes a long time to heat up. Max, stop. Stop. Sorry, he's like, oh no, she just said done. I'm still live, right? Okay, good. Sorry, my little thing in my ear said done. So land and sea breeze. Water takes a long time to heat up. Think if you've ever tried to like boil water to like make mac and cheese or whatever. So because water takes a long time to heat up, it also takes a long time for the ocean to heat up. So during the daytime, the sand is going to heat up very, very fast. The ocean is not going to heat up at all. So your ocean might change like 1 or 2 degrees, whereas the land is going to change like 15 or 20 degrees from when it's sun to no sun. So the hot air above the land is going to rise, so the cool air from the ocean breezes in. Then at night, what's going to happen is the land, as soon as the sun goes down, the land cools down instantly. The ocean is still holding on to a little bit of that heat from the daytime. So now the ocean is warmer and the land is cooler. So now the hot air over the ocean is going to rise and the cool air from the land breezes in. So that's why at night you have a land breeze. That's how wind is created, is because of the uneven heating of different surfaces of the earth. You've got 4 types of pressure, or 4 types of fronts. Cold front, which are the blue icicles, triangles. Warm fronts, which are like flower petals or sun petals because they grow in the warm weather. They're red. A stationary front, that's the one with the red going one direction and the blue going the other direction. I'll explain all the fronts in a second. And then occluded is purple, and it's the same direction, but it's going to be both the warm and the cool front symbols on the same line, and they're going to be facing the same direction. So for a cold front, warm air is or a warm air mass is in the area. Cold air is more dense. So what's going to happen? If here's my warm air mass, my cold air mass is going to come in and it's going to go underneath and push that warm air up and out. So the area left behind is cooler air. For a warm front, you've got cool air in the area. Your warm air is not strong enough and not dense enough to like move under it, but it's going to come in and it's going to kind of slide over like that so that the cool air is pushed out and the area becomes warmer. So for a stationary front, you've got cold air and warm air, and they're going to kind of meet head to head. Neither one is strong enough to push each other out of the way, so they stay stationary. They're going to stay in the same place for a long couple of days usually, whereas a cold front moves through, like you've noticed, if you're at school and it's 50 degrees in the morning and then it's 30 degrees when you got out of school because a cold front came in. That can happen in a couple of hours. And then the last one is an occluded front. That's the hardest one. It's similar to a cold front, but don't get them confused. A cold front is 1 cold air mass. Occluded is 2 cold air masses. So you've got cold air and you've got cold air. Up here in the middle, you've got warm air. What's going to happen is these 2 cold air masses are going to come up together and they're going to join forces and push that warm air up so that it gets cut off from the surface. And all you have left is just the cold air. So it's going to feel like a cold front, but it's not. You always know which direction a front is moving based on which direction it's pointing. So all of these are pointing south. So in this instance, the fronts would all be moving south. Low pressure is the big red L. That's going to be stormy weather. L for low, gloomy, stormy. H for happy. That's happy weather, high pressure. I think that's all for that. Tyler says, what did we learn at the beginning of the year? The very beginning of the year, we did chemistry. Then we moved into the universe and we did like galaxies and we did moon phases and stars. Then we moved into solar system. Maybe some of that was in that. We did it's a bunch of different, like one of stars is in one of them, galaxies, moons, the Galilean moons, comets, meteoroids, asteroids, lots space stuff. And then we finished the fall semester with was it those 3 units? Now I can't remember. Hold on. Let me look at Google Classroom. I can tell you the units. So I want to make sure I don't forget. Okay. So fall we had chemistry, solar system, universe, and then spring we've had physics, energy, natural resources, atmosphere and weather, and plate tectonics. So those are the different units we've had this year. I don't know what you may have had in other years, but like the order of them, I know what you had, but I don't know what order you guys did them in. So it's about 10 till. So do you guys have any more questions? There's about 10 of you still hanging on. So thank you for staying in here. Let's see if there's anything we haven't got. Waves, totally forgot about that. We did waves at the beginning of the year. You've got electromagnetic waves. Those are the waves that can travel through air, vacuums, space, everything. They do not need a matter or a medium to travel. Mechanical waves do need a matter or a medium to travel. Sound waves. So right now, there's air molecules around me, and I'm making those air molecules vibrate with my voice, and that's how you can hear me. If I was in outer space, you would not be able to hear me because there's no molecules. So sound is a mechanical wave that must have a matter or a medium to travel. Transverse waves make matter and the energy go perpendicular. So the matter goes this way, the energy goes this way. It makes a T for transverse. Compressional, the matter and the energy go in the same direction. So a sound wave, the matter, which is the molecules, and the energy, which is my voice, are both traveling in the same direction. So that's compressional. Okay, so Cole's asking about the Doppler effect. So that was the when the siren or a car drives past you. So when the waves are coming towards you, they're going to be bunched up and it's going to be a much higher pitch sound because the waves are close together. So short wavelength, high pitch, high frequency, high sound, whatever. And then after the siren or the car or the truck goes past you, the waves get spread apart. I know, good sound effects, right? After the wave goes past you, the wavelength gets longer. Long wavelength, low frequency, low pitch. Blue shift is items coming towards us. The wavelength is shorter. Blue to red away. Red shift, the items are, the wavelengths are longer. Yes, like NASCAR, exactly. That is a great example of hearing Doppler effect. Radio waves, your longest radio wave is a radio wave. The longest electromagnetic wave is a radio wave. The shortest is a gamma. All electromagnetic waves, no matter the wavelength, travel at the same speed. Let's see. Somebody had asked about energy transformation a long time ago. We talked a little bit about it at the beginning, but heat transfer, you've got convection. Convection is the same thing as like land and sea breeze. The hot rises, the cool sinks. Conduction, that's hot and cold molecules touching or coming in contact. And then radiation is like warming your hands by the fire. So that's the heat transferring through the air. Energy transformations, you've got chemical, which is energy that's stored, mechanical, which is moving, radiant, which is light energy, electrical, which has a plug, thermal, which is heat, sound, which you can hear. Potential energy is the object's potential to move. So like this bottle cap, it has the potential to move, but it's not. It could, but it's not. It's due to its position. And the more potential energy an object has is due to its height or due to its mass, due to its height or its speed. Speed, mass, I don't know. I have to go back and look at that one. And then if it's got kinetic energy, that's object of motion. So that's going to be if it has more mass or if it has a higher speed. When did we do that? That was the beginning of this year, not the beginning of this semester. Plate movement. Let's see, energy, natural resources. So that would have been that videos to help. There's videos on there for I want to transfer if that helps you. Oh, I clicked the wrong thing there. Not a concept check. We don't want that. Let's see if this is it. Loading. There's pictures of my notes from I was trying to get the glare because like I've got a window so the sun is shining right in there. Convection, conduction, and radiation. There's my notes for that one. That's clearly not the one I wanted. Always changing. Let's see if this is it. Nobody else has questions? You guys got around 5 minutes or something? Good pictures of potential and kinetic energy. So potential is at the top. Kinetic is in motion. The greatest kinetic energy is at the bottom of the hill. The greatest potential energy is going to be at the top. Potential energy, more height, more mass, more potential energy. So it was mass. Sorry, I couldn't remember. It's been since February since we did that. Yes, potential. Well, chemical energy is energy that's stored. Potential is energy due to its position. So not quite the same. What else you got? I'll go back to my little STAAR booklet thing. I should have saved it as like a picture because I keep having to go back to it. I've been streaming for an hour, but I started a little early. So you guys have around 5 or so minutes, especially if there's no more questions. Then I'm going to for sure log off. But if y'all have more questions, I'm happy to stay and go over whatever. Look at Google Classroom. There's a ton of Quizlets out there. There's all kinds of stuff. When you go in and you click on, I'm trying to see, the little STAAR topic categories, a little gray box that says STAAR. If you click on that, that will categorize everything I've posted about the STAAR test to help you study. That little booklet, it's a packet because I didn't get it folded into a booklet, but that little packet has an overview of everything you have a chance of seeing. At least we hope everything. We don't know. Remember testing strategies. If you don't know the answer to something, figure out which answers are wrong. Like, can you rule anything out? Go back and underline keywords, circle keywords, figure out what the question's asking. Remember, sometimes there's going to be like a lot of fluff. They might tell you this whole story about a dog like Max. And then, by the way, they're going to say, when the dog runs, what kind of energy is it? You don't need to know the whole story about the dog. All you need to know is what kind of energy is moving. So yes, Cole says the strategies were wake. W, what is the question asking? A, analyze pictures, graphs, or charts. Tons of times the answer is in a picture, graph, or chart. So don't forget to look at the pictures, graphs, and charts. Don't skip them. K, circle keywords, and E is eliminate answer choices. Tyler says, what are the levels of recovery from like a wildfire? So I don't know if that's going to come up or not, but like if there's an actual wildfire, depending on the amount of damage, that could damage the area. So it has to kind of like regrow through that. We've never really studied that. That's more of a 7th grade thing. Sometimes in a controlled burn, that's good because it can kind of help regrow an area. I'm not super familiar with that, so I don't know. Hopefully that won't be on there since I don't really know a lot about it. Cole says, hurry up and ask. Well, he didn't say hurry up. I did. He said, can we do hurricanes and tornadoes? So both form under low pressure. You saw it on the scavenger hunt. Yeah, that's for sure a 7th grade topic, Tyler. But if you have that packet, go back and look at it. I don't have it with me because I left a stack of stuff at school today that I meant to grab to bring home for the review. But if you go back and look at the 7th grade packet, it's also on Google Classroom, Tyler. If you didn't bring your folder home, I posted that packet on Google Classroom. But hurricanes and tornadoes, Both form under low pressure. Tornadoes start in a strong thunderstorm, and tornadoes need dry air from uh, like the deserts of like Arizona, California, New Mexico, that west part of the United States, cold air coming down from Canada, and then they need warm, moist air coming from the Gulf. So because Texas and Oklahoma and Kansas and Missouri, kind of all right down the middle, all have those three air masses combining, we have Tornado Alley because we have most of those three air masses. If you're over in New York, you're not getting that warm, dry air from the deserts. If you're over in California, you're not getting the warm, moist air from the Gulf. So that's why we have the most tornadoes, because we have the melting pot of the three air types needed to form a tornado. Hurricanes, and tornadoes are measured by damage on the Fujita, however you want to say it, Fujita wind damage scale. So it's the damage that we're looking at. That's what's going to measure how bad a tornado was. So if it's an EF0 or an EF1, that's a low damage tornado. EF4, EF5, you're talking about devastation, like the entire neighborhood is gone. Succession, I'll get there in just a minute. Let me finish with hurricanes real quick. So hurricanes are going to form only around the equator because it needs warm water from the actual ocean itself. The warm ocean water is what fuels the hurricane. Evaporation of the warm water into the air is what moves the hurricane. And then the wind has to swirl inward on the surface for that hurricane to get going. So as long as they're in the ocean, they can gain speed and pick up energy. Once they move on land, they're going to die out. So both of them come from low pressure. Hurricanes are not going to happen on the West Coast because the water in the ocean is too cold, because the California current brings water down from the north. So that's too cold. That's why you never have hurricanes hitting California. But we always have hurricanes in the Gulf, Florida, up the East Coast, because we have the warm Gulf Stream bringing that warm water, which makes the conditions perfect for a hurricane. As soon as a hurricane goes on land, it's going to lose its power, lose its speed, lose its momentum. All tornadoes start out as tropical depressions, then it gets upgraded to a tropical storm. When the wind speed picks up enough, it goes up to a hurricane. As it starts to die, then it goes from a hurricane to tropical storm, back down to tropical depression again. So it's kind of like a pyramid of wind speed. And that is the Saffir-Simpson wind scale, and that is how hurricanes are measured. Is succession the land changing over time? That's a great question. That's another one of those 7th grade things that I'm not 100% familiar with. So let's see if succession is on here. I would think the rock cycle, I know we talked about that earlier. The rock cycle is in your packet. Where is succession? Okay, catastrophic events. So you've got your rock cycle, and then it's talking about the water cycle. Just below that, it mentions succession. It says, I know you can read, I'm going to read it myself to figure it out, and then I'll explain it. The ongoing process of environmental change that happens in a predictable pattern following a disturbance. So plants and animals tend to return to the edges. So that is what's happening after your main storms. Succession, I think it's Reedy was the mango juice. Is succession the land changing over time? Yes, succession is the land changing, but it's changing after an event. So like Tyler mentioned, recovering from a wildfire, succession would be the land regenerating, regrowing. It's the rebirth, I guess you could say, of an area. So it's any disturbance. So a tornado comes through the area, then the area has to go through succession to become successful again, or to regrow and to like get all of that better. Cole has to go. Thank you so much. Thank you for joining in and asking good questions. Yes, the Bachelorette started at 7, but I'm still here, Arjun, because you guys still have questions. Plants and animals tend to return. So succession is going to start at the edges, and it's going to work its way back to the middle as the land gets healthier. So if you had a wildfire, like they have in California, a bunch of wildfires, the succession of that is going to take a lot longer, because it's going to take a lot longer for everything to heal and for animals to move back back into an area. If you have a tornado, it's a smaller kind of area, so succession could happen, faster in that kind of a place. What else? Plate tectonics. We haven't talked about any plate tectonics now. Tyler, don't be talking about The Bachelorette. It's a great show. I like mindless TV. I don't have to think about anything. I can just watch someone else's life be a mess. Continental drift is the plates that are drifting and moving. Plate tectonics is that the continent or the Earth is divided into plates. Divergent boundaries are separating or splitting, moving apart, and that's going to cause a rift or a ridge. Convergent, if the plates have convergent, if they have equal density plates, then the plates are going to come together and make mountains. If it's a convergent boundary, but the plates are not equal density, you're going to have a subduction zone. So that's where an oceanic plate, which is more dense, is going to subduct and go under the continental crust, which is less dense. And that's where a trench forms and volcanoes can happen. And the last one is transform, and that's where the plates slide side by side, and that creates earthquakes. Tyler, you're not giving spoilers about The Bachelorette because it just started 4 minutes ago. No one dies on that show. Come on now. Wegner is the guy that said continental drift was happening. He gave pieces of evidence. He said the continents fit together like a puzzle. Coal was found at the South Pole, which coal comes from dead plants. Dead plants could have only been growing in the South Pole, Antarctica, if the area was warmer, which suggests Antarctica was further north. Plants grew, they lived, they were happy. When the plates all split up, the continents all split up, and Antarctica moved south, all the plants died because they froze. The plants over time became coal. Coal was found in the South Pole, so that's how that shows us continental drift. Third piece, fossils from on different continents across the Atlantic Ocean. The Atlantic Ocean is humongous. So we have these dinosaur families. They couldn't fly. They couldn't swim. So how did their families' fossils get on opposite continents? Well, if the continents were together and both the dinosaurs lived together, here and here, then it split. Some dinosaurs were here, some dinosaurs were here, and then their fossils ended up on opposite continents. The matching mountains and rocks. So we've actually got mountains in the United States that match with mountains in Scotland. So scientists say that mountain range was one big long mountain range, and when plate tectonics kind of started happening, the mountain range broke. So now the rocks on one side match the rocks and the mountains on the other side. And the last one, glaciers. So the way the glaciers split and broke, scientists could look at the markings. They're called striations, or like stripes or markings on the glaciers, and scientists could say this glacier broke from this glacier, kind of like a puzzle piece. They could kind of say, this edge fits with this edge, or like a broken plate if you were gluing it back together. The scientists said the plates moved because convection currents in the mantle. So once again, convection, heat rising, cold sinking. I would definitely remember convection. That's a huge thing. It happens in weather and atmosphere to create wind, land, and sea breezes. It happens in plate tectonics for the mantle. It happens in heat transfer for convection of boiling water. Definitely no convection. I think we covered like almost everything. You guys asked a lot of really good questions. We've done periodic table a little bit. We did consumer, producers, parasites. I'm looking at the review thing here. We did organisms, eukaryotes, prokaryotes. Euc equals nuke. Pro means no. Watershed, atmosphere, and weather. Plate tectonics, succession. Moon phases, we didn't really go over moon phases. Go watch the moon phases wrap. That will help get that order of the moon phases stuck in your head. They're in this little thing here. If you want to look at the phases, go draw the phases, go practice the phases. Go back on Google Classroom, look at the moon maps. You can see 29.5 days. If you want to go half, 14 days. A quarter is 7, and then that means each phase is going to be about 3.5 days. Seasons happen because of the tilt of the Earth. So if it's tilted toward the sun, the north, we're going to have summer. If it's tilted away, we're going to have winter. If it's not tilted either way, that means we're side by side. That's fall and spring. Rotation happens every 24 hours. That gives us day and night. Revolution happens every 365 days. That's what creates years. Spring tides happen. Spring tides are the biggest tides. Spring tides spring up, and those are going to happen on full or new moons. Neap tides, neep, 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 little small tides are going to happen on a first or a third quarter. We did the systems, we did cells. We didn't go over stars too much. We did life cycle of a star, HR diagram. Typically, they like to give you guys the HR diagram and ask you to read it or go over it. Rock cycle, we did that. We really went over a lot of stuff. 3 types of galaxies. We live in the spiral galaxy. The sun is located on the arm of the spiral galaxy. Our galaxy is called the Milky Way. Food chains and food webs. The arrow points to what it's eating. So if I had a worm, the worm is going to point to the bird because the bird is eating the worm. The worm energy is going to the bird. Producers, again, are your lowest level consumers. Eat them. Go look at chemistry, guys. There's always a lot of chemistry. I cannot stress chemistry enough. Go back and look at everything chemistry. Go back and watch that video we posted, we did in class. Practice the periodic table. Do that first thing tomorrow. Topography, we talked about that. Metals and nonmetals. Metals want to lose electrons. Nonmetals want to gain electrons. We did physics, force and motion, balance, unbalanced. We did waves, and we did heat transfer and energy transfer. We really covered everything in that little booklet. I like how Arjun has jokes. He wants me to go over all 10 of the practice STAAR worksheets we gave you guys. Those are just questions from old STAAR tests. A lot of them are from your concept checks and your tests. All your concept checks through the whole year have been STAAR questions from years past. We give you old released questions on purpose to help you practice so that you struggle early in the year. You don't struggle on the STAAR. Where are metals, metalloids, and nonmetals? So your metalloids are the stair step. Your metals are on the left. It's the big, huge section. And then your nonmetals are on the right. So look, where helium, oxygen, nitrogen, all those gases, those are nonmetals. So if you can't remember, hopefully seeing those gases, nitrogen and oxygen, helium, those are all of your nonmetals. The only exception is hydrogen. It's the one gas on the metals side. And then on the stair step, every element on the stair step except for aluminum. Aluminum is a metal, but it's on the stair stepper. All right, guys, it is 7:11. We've gone 10 minutes over, which I'm happy to do because you guys were asking good questions. Who has the most energy in a food chain? Whoever's at the top has to eat the most. So like it's the rule of 10%. And I want to say it's in here. Let me see. So if you look at this little, the angles and the light, the reflection, because it's a cell phone. So the energy, the producers at the very bottom of the food chain are going to have the most energy because they don't have to like get their food from somewhere else. They're making their own food. So plants have the most energy. Any food they make, it's all theirs. They get to have it. They get to eat it. So then like a rabbit that eats the grass has to eat more grass than it needs to get the energy it needs to survive. And then if you have like a bobcat above that, it's going to have to eat several rabbits because it's not going to get 100% of the energy from the rabbit in the grass. It's got to eat more. So as you go up the food pyramid, the amount of energy is going to decrease. And this is in that little booklet that we gave you. The view is horrible. Right there, you can kind of see it. So yeah, oof for the rabbits because he's always going to get eaten. That's why you also have less a population of your big killer animals because they're all having to fight for the smaller ones and they have to eat more of the smaller ones to try to survive. So I think that's pretty much it. Unless you guys have any last minute questions, I'll give you a couple of minutes to see if you have any last minute ones. If I don't hear from anybody in the next minute or so, I guess we'll call it a night. But you guys have asked a lot of really great questions. Like I said, take your time, go through your strategies. If you're a kind of person that knows you struggle with something, look at those questions first before your brain gets tired. Is a food web different than a food chain? Yes. A food chain is just one string, so it might be grass, rabbit, bobcat, whereas a food web is grass, rabbit, grass, deer, and then the deer gets eaten by, I don't know, the human, something bigger. So a food web is several food chains put together. So a food chain is smaller. It's just one singular string of like 3 to 4 organisms. A food web is like the whole thing all together. It's like 10 organisms. And that is also in this packet. If I can zoom. So there's your food chain on right there. You can kind of see like a little food chain. It goes from plant to insect to mouse to owl, whereas the food web incorporates a bunch of different organisms. So good question there. Is the energy the same? It's the same thing I just talked about with the pyramid, which is when you find your packet, it's going to be right there in the same area. So yeah. Anything else? Lots of good questions. I think you guys are more ready than you feel like you're ready. You're 15 minutes into the Bachelorette. Thanks so much. Thank you, Arjun, for respecting that I'm into the Bachelorette. But I'm recording it so I can go through, and if I'm honestly behind a little bit, that's okay, because then I don't have to watch the stupid commercials. I can fast forward through them. But I'm sure it's going to be like 2 hours, and I'll get caught up really quickly. But yeah, I think that's it. Take your time. You guys are going to do great. Don't stress. Don't worry if you have a question you're stuck on. Should you guess C? I don't know which answer you should guess. If you don't know the answer, please don't just pick one. Go through and for sure see, is there one that you know is definitely not the right answer? Because then you only have 3 or 2 answers to choose from. But if you just guess out of all 4 of them, that's like a 25% chance of getting it right. So see if there's anything you can roll out. Look at what the question's asking. Really think with those strategies. Take your time. Go through and answer the hard ones first if that's something you like to do. Go back and check your answers. If you're stuck, go with your gut instinct. Don't second guess yourself and talk yourself into a wrong answer. Reedy's asking to my dog. He's going to be crazy because he's locked up in my bedroom, which is why he hasn't been barking. So, yeah, let's see. We'll go get him. Hold on, I don't want to get stuck on my cord for my cell phone. Okay. You guys get a nice little ceiling view here. He's about to go crazy. Where are you going? Come here. Come here. Up here. Oh, okay. Come here. So here he is. He's really excited to be not locked up anymore. So, all right, guys, I guess that is the end of the review. Almost at an hour and a half. That's awesome. Lots of good questions. Does my dog do any tricks? He probably is not going to do any right now because he's really mad because I locked him up. Do you want to go outside? I locked him in his cage not in his cage, I'm sorry, in my bedroom around 5:45. So he's probably pretty mad because he's been in there since 5:45 and it's now 7:15. So he's not really very happy with me right now. He has some toys and let's see if he. Want your baby? Sit. Up. He's like, no, I'm not doing that. So if he gets a treat, he has to go sit. Hold on, sunshine. If he wants a treat, he has to go sit in a certain place and he will. See, he just heard me say it. So now he's like really excited. He's like, yeah, I want it. And I can spell. Okay, I'll spell, then I'll sign off. So, okay, hold on. Can you see him? Hey, Max. D-O-G. Where are you going? He normally doesn't react for that. Come back. Come here. Look. Come back. Where is he? Can you see him? C-A-R. So yeah, he knows He knows that one because he wants to go. So, all right, guys, that is it. Hopefully the review helped you guys. Go back and watch it. Go back and look at all the stuff on Google Classroom. Yeah, so hopefully this helped. There's about 7 of you left. So thank you guys. You guys are awesome. Thanks for studying. Thanks for asking good questions, helping me guide this, because if I had to talk and just make stuff up for an hour and a half, it would have been crazy. So do your best tomorrow. Good luck. You guys can do it. So have a good night. Bye. Now, how do I stop it? End stream. All right. Bye.